One of the most common questions I get asked is, can I use deep learning for that? So typically this comes from friends and colleagues that are not doing deep learning actively at work, but want to use it to solve some sort of tedious task at work. And so typically the way I like to reframe that question is to ask them, is your problem a supervised learning problem? If it is, then it's easy to solve. If it isn't, do you have a way to turn it into a supervised learning problem? If you do, then you can solve it. And if you can't, then it's actually pretty hard to solve. Instead of thinking of a neural network as a bunch of neurons, I want you to think of it as a function that goes from one input space to an output space. So let's cover a few examples to show you what I mean. So let's say you're trying to implement a pedestrian detection algorithm. So in this case, your input data is a 2D or a 3D image. And your output data is a bunch of bounding boxes, depending on how many pedestrians are in the image. Or in the case of translation, you're going from an input space, which is a vector of cars in one language, to an output space, which is also a vector of cars, but in another language. And the data structures can be arbitrarily complex. So let's take the example of a spam classifier, where your input data could be whether the sender is on a blacklist, what the email subject is, some featurized embeddings of the email content. And then your output space is basically just a binary classification. Is this email spam, yes or no? How come I'm saying that neural networks are a black box? Like what about, like hyper gradient optimization and super Hessian techniques? Well, the thing is, like, this framework helps you figure out like what is like solvable theoretically but it doesn't tell you what's solvable efficiently. To solve things efficiently, you need to do things like think about your network architecture, your data augmentation strategy, your loss function, your optimization strategy. All of these are engineering details and will help you figure out what is theoretically solvable by deep learning. So many problems that don't at first look like supervised learning problems actually turn into one. For example, reinforcement learning involves an interaction between an agent and the world. And you can cast this as a reinforcement learning problem if you view the input space as your world state, and then your output is the action that your agent needs to take. Similarly, transformer models are typically trained on an unsupervised corpus of text like the internet. But their training mechanism very much looks like a supervised learning algorithm. Transformer models are trained in one of two ways. Masked language modeling, where you're trying to predict what a given word is given its surrounding context. Or next sentence prediction, where given two sentences, you're trying to predict which sentence came first in the corpus. The nice thing about thinking about neural networks as functions from an input and output space is you can start composing them. So you can do things like, well, if you have an object detection neural network and object classification neural network, you can compose them, or you could take the product. Let's say you had a neural network that created an image embedding and another neural network which created a depth embedding. You can combine these two states into a world state for a reinforcement learning algorithm, which then takes an action on this combined state. Finally, I'm personally very excited about invertible neural networks. We're assuming that you wrote an invertible neural network to solve the graphics problem, which takes in a 3D scene as input and creates a 2D image as an output. You can also solve the inverse problem, which is photogrammetry, which takes in a 2D image and then figures out the 3D scene from it. So I hope this was helpful. I've personally found this framework invaluable when I think about what kinds of problems can I actually solve with supervised learning. And it's one which I think has found a lot of success with my friends and colleagues. So I hope you found it helpful. And if you did, please make sure to subscribe.